Hello everyone, welcome back to our fourth and final attack detection fundamentals workshop for 2021. If you joined us last week, we took our first dive into some cloud attack detection, and in this final workshop we're going to be following that theme and be looking at Azure, or most certainly Masande will be looking at Azure. So firstly, I guess it's only right for me to say, welcome to Masande and thanks for putting the content together. He's going to be taking us through the entirety of this content, so we'll be joining him in just a moment. The thing for me to do right now is just to give you a brief overview of the goals of the series. For those that have joined the previous workshops, I'm sure you're well acquainted with this, so I apologise. But goals of the series: ultimately, we want to perform some attack techniques, show you kind of how they work, and then hopefully kind of provide you with a bit of insight into how you might detect or even prevent them entirely. We're going to be keeping it, hopefully intentionally, as the workshop series title suggests, pretty kind of fundamental. Hopefully the things we're showing you are things that are basically how your enterprise products likely work under the hood, particularly when it comes to kind of the cloud services we've looked at in the last two workshops. They're going to be primarily some of the kind of SaaS solutions that you're dealing with and some of the logs that are provided by the cloud service providers themselves. In terms of how, as you kind of well know, hopefully analyze the TTPs. We're going to emulate them in a controlled lab environment, and then we're going to observe the traces that they leave. So nice and simple. The format hopefully is something that you're very well familiar with. And just with this one and all the ones before, we're going to keep it as simple as we possibly can. Obviously, when it comes to cloud and cloud assets, we don't have a single endpoint like we did with Windows or the Mac workshops where we can just kind of do the attacks in isolation. So Masande has prepared some Terraform to spin you up an Azure environment that we're going to carry out an end-to-end kill chain in. So the lab environment itself will be made available. Indeed, it's available now. And there's a link to that in the lab guides, which are also available now on the F-Secure Labs website. And then finally, the slides for this presentation and the recording of this presentation will all be available most likely tomorrow. So series overview, just to go through what we've covered briefly. I think we're obviously at the very end now. So we've covered off some Windows and Mac OS endpoint detection. So we obviously had myself and Ricardo for Windows, and then we were joined by Callum and Luke for Mac OS. We then, as I said, took our first dive into cloud attack detection with AWS last week with Nick and myself. And then finally, as I say, we've got Masande to finish us off for 2021 with Azure. So with all that said, I am going to pass over now to Masande to take it from here. So thanks, buddy.
Cheers, thanks, Alfie. Right, so let's get started here. So let me just get everything sorted out on my end. Okay, so in this workshop, we'll be focusing on how we can start thinking about attack detection in the cloud by walking through an end-to-end attack in Azure. So we'll start off looking at how we can get initial access into an environment, moving on to privilege escalation, and then achieving a particular goal an attacker might have. At each stage, we'll take a look at the log events that we have created from the different log sources that Azure provides. And then after we look at the log sources, we'll try to see what attributes of these log events we can use to build detection capabilities. Through this all, we'll also identify some of the challenges one might face when reviewing these logs. So we've put together an attack that has 4 stages, starting off with consent phishing, which is a type of phishing attack that allows a malicious app to impersonate a user. And then we've got internal reconnaissance, where we'll be using a low privilege account that we discover to further on discover additional hard-coded credentials in an application that will give us privileged access into our environment. And then finally, we'll look at defense and lateral movement. We've combined these two together. What we'll be trying to do here is try gain access to sensitive information on a specific target resource. And while doing that, trying to evade some of the security monitoring that might be deployed. Right, so before we begin, let's just describe the environment that we'll be working with. So in our diagram, we have a subscription, which is a place where all resources are created. In it, we have a resource group, which logically combines resources, typically that revolve around the same application lifecycle or just broadly related to the same application. Then we have three resources in this resource group. So we've got two Azure VMs. Then we've got a logic app. What logic apps are a PaaS service that performs some set of actions, but later on we will dive in a little bit deeper to explain what logic apps are. And then outside of our subscription, we have Azure AD instance where it will serve as our identity provider. And lastly, we've got a log analytics workspace where we'll be taking all the logs from both our Azure AD instance and our subscription and shipping it off to the log analytics workspace so that we can perform some querying and see if we can spot some malicious activity. As Alfie mentioned, to help simplify setting this all up, we have provided a Terraform code which will made available after this presentation, so it'll go ahead and spin up most of what you are seeing here at the moment. So in terms of telemetry sources in Azure, the ones that you will find is Azure activity logs, which typically contain sign-in and audit logs, so things related to users signing into the environment and things they perform after they have authenticated in the environment in Azure AD itself. And then we've got activity logs, which relate to log activities that a user performs in the subscription, but more at a control plane level or managing of the resources themselves. When we look at the resources themselves, we've got what's called resource logs that provide information of what has happened within the resource. So if you think of the case of Windows VMs, Windows event logs will be something that is relevant here. Lastly, we've got network logs. In Azure, they are called NSG flow logs. So yeah, it's good to keep these four log sources in mind when you are performing attack detection in the cloud. So we've put together 3 labs that take us through the different stages of the kill chain. So we're going to be starting off with consent phishing. And then the second lab will be hunting for credentials using a low privilege account. And then lastly, we'll be performing lateral movement and defense evasion. So let's start with our first one, consent phishing. So similar to common phishing, consent phishing relies on convincing a user to perform an action. So that action could be clicking on a link. How consent phishing works is through abusing a feature that's provided by cloud providers that allows users to delegate their permissions to an application. So this feature is provided by Azure AD, and it's you can, in some places in Microsoft documentation, you'll find it referred to as Azure AD consent framework. So to understand how this particular feature works, let's take a closer look at Azure AD. So yes, so Azure AD is an identity and access management solution provided by Microsoft, which essentially holds the different identities in your environment, so users and applications. In the case of application, they are known as service principals, or in some places as enterprise applications. Azure AD can also function as a single sign-on. So for applications such as Salesforce, Office 365, and Azure subscriptions, it serves as a place where those services offload their authentication to Azure AD to handle that for them. One thing to note about Azure AD is that it also stores useful information about users. So information on their names, the department they might be in the company, their email address, and a bunch more of other related information. Why I'm pointing this out is that it becomes relevant when you consider a scenario of a developer who is creating an application, and they want this application to pull information from Azure AD into the dev's own application. So for an application to be able to do this, it needs to be registered in Azure AD, and then a user has to consent to this application to be able to access this information. So what we're going to do now is take a look at how this all happens under the hood. Right, so how this is done is in the case of a dev building an app for users in the same organization. It's also known as a single tenant application. The first thing that needs to be done is the person creating the application needs to register the application. Part of registering the application creates something called an app registration, which is a template or blueprint that defines your application. So it gives the application's name and what specific permissions this application might need. So just to point out some of the permissions that might be required by the app is reading the Azure AD data that we previously discussed, or accessing Exchange Online, etc. So Azure AD takes this app registration and creates a service principal in your tenant, and then this service principal will, from that point onwards, be what's responsible to talk to those service providers that host your information that you're interested in, or Azure AD to pull this information. How the service principal gets created is when the user accepts that this application can have the specific permissions that it requires. In some cases, though, you might want to create an application that users in one tenant will. So let me just rephrase that. So you might be a part of organization X where you've created an application and you want users in organization Y to be able to access that application. What you will do is for the application in organization X, the user who is in organization Y will visit a link that will request from the application if it can get a set of permissions. Once they accept these permissions, the app registration is used to create a service principal within organization Y. So let's take another closer look at how a user grants an application the specific permissions. So when a user visits an application that is registered with Azure AD for the first time, they may be redirected to a consent framework screen. So the screen, as you can see, explains the name of the application, what organization created the application, what permission the application needs. So here it's asking to read your emails, have full access to your files, etc. So when the user accepts the consent request, in the background, what happens is that the app registration is used to create that service principal that now has access to the user's information. So it's sort of performing what we just previously discussed all in the background. Just for interest's sake, if you log into Azure AD and go to an enterprise application, you can get a full list of the applications that have been created in your Azure AD tenant. They don't necessarily have permissions, but the permission information can be queried from the portal or PowerShell or any other command line tool that you use. So now, given our understanding of how Azure AD consent framework works, let's take a look at a real example of consent phishing attack. So in this email on the right, a user had been requested to change their Auth365 password. They are then requested to click on the link that's in the email. Once they click on that link, it redirects them to the consent request page, which we can see here on the right. The application is requesting for read contact permission, so forth, similar to what we previously looked at. If they were to click accept, the app will then have those specific permissions, and consequently the app owner would be able to query that information if they desire. In the first lab, we'll be replicating a similar attack against a victim user. The tool that we'll be using for this is the Auth365 attack toolkit. Just a little bit more information about the tool. The Auth365 attack toolkit is an open source tool for conducting consent phishing attacks. It provides the capability to generate links that will be sent to our victim user when they click it, and it will also request excessive permissions that the application is requesting for. The toolkit provides is composed of two services, which you can see in that blue block there. There's an external server which is used to monitor for users that have been successfully phished. And this information is conveniently displayed to us in the management interface, which is the second service provided by the toolkit. Besides providing a nice interface for us to see which users we have compromised, it also makes it relatively trivial to query the users for sensitive information that they might have access to. So searching through their email inbox or searching in SharePoint. But yeah, I think let's now speak. I think a good way to now understand how this all looks is through our first demo. So let's have a look at our first demo where we'll be performing a consent phishing attack. Right. So what we're doing here is we are starting up the toolkit. You'll see here there's two servers started. We'll take the first one, which is the internal server, which hosts our management interface. We've opened up the management interface now. We can currently see that there are no users that we have access to. So we'll generate a link, which we'll send to our user named Sydney Gray. We're just asking them, can you please sign up for this service that the organization is using? We put the link in a hyperlink, and then we send this email off. Then now let's switch over to our victim. So the victim will now open up their Outlook and wait for an email to arrive. Now they see the email arrive in the inbox, and then they will go ahead, click the link, taking them to that consent request screen that we previously discussed. We can see what the app name is, what permission it requests. Once they click OK, the toolkit gets information about their token, and then they are redirected to the Office 365 page. So now let's see this user that we've compromised. If we go to search emails, we see there's nothing there, but we will then put in a keyword for a secret. It'll search through its inbox to see if there's any ones that have secret in it, and then it provides this information for us. Right, so before discussing detection, I think it might be worth quickly covering how we could mitigate this risk. Ideally, what we want to do is disable the user consent feature, but there are valid business cases where organizations might want their employees to be able to do this. So having some sort of control over which application they can consent permission to is an option that is provided. So we can restrict the application based off their reputation, based off Microsoft's evaluation of the app, or if they are a verified publisher, which is a arduous process to get signed up with. Lastly, you can just keep it how it is, but I have broadly simplified this. There are other variables that you can play with to make it more suitable for your organization. But if you are interested in that, Microsoft documentation is a good place to consult on that. So for us to be able to detect consent phishing, we will need to understand the types of logs that are available. All logs that are generated in Azure AD are made available from the portal, but also since we have set up log analytics, all that information is shipped there. The two types of logs that we have is sign-in logs and audit logs. Sign-in logs will provide, as it says in the tin, information about sign-in activity for users and service principals. And audit logs is what are the users they performed on Azure AD once they had authenticated. So on this demo here, we're just going to be showing us querying, performing a query in Log Analytics workspace to see what actions were performed when the user accepted that consent request. So we're saying, please give us all audit logs for our user, Sydney Gray. We can see that there are 4 operations that were performed. So adding for service principal, permissions being delegated, a role being assigned, and then consent to application. If we drill into the permissions that were delegated, we can then get information related to what were the specific permissions that were given to the application. So we can see there that they had read access to our email and could send emails on our behalf. Just to quickly go over those same events that we just discussed. First thing that happened is there was an add service principal, which was the toolkit itself being added as a service principal in our tenant. Then certain permissions were assigned to it. Thirdly, there was a role assigned to it, which is more of a role that's the user has now on the application, but isn't too relevant in terms of from an offensive perspective. And then lastly, there's consent to an application, which is essentially just saying that the application has been considered some privileges. Right, so we looked at the log events that could help us detect some of the consent phishing attacks, but it's worth acknowledging some of the native detection tools that Microsoft provides to do the same. Microsoft has built-in queries for several of their services that simplifies searching for consent phishing. Some of these services are Microsoft Cloud Application Security, which is their CASB solution, Azure Sentinel, which is their cloud SIEM, Azure Workbook, which is a platform for users to perform data analysis and visualization. It also has built-in queries, which performs this detection of this consent phishing attack. Lastly, the queries that are provided by these different platforms can be wrapped up into alert. So when they are discovered in your logs, it will be notified. Alert will be sent out, and the relevant people would be notified about it. So now, after getting the credentials from the user's email inbox, the next thing to do would be to understand what permissions your app has. If you're lucky, you would have access to a high privilege account, which would give you full control over the environment. But let's start with the assumption of only having a low privilege, which is the read-only permission. But yeah, in due course, we will be showing that that is the case and see what we can do with it. So if we want to discover additional credentials, we'll need to know what are the services that could potentially provide us a path to do that. So a good place to start would be looking at the commonly used PaaS services in Azure. So these sort of the three that we've sort of seen quite often in engagements is Azure Function, Azure Automation Runbooks, and Azure Logic Apps. Just a brief description of what a PaaS service is. So a PaaS service is essentially a service provided by the cloud providers where they handle most of the infrastructure responsibilities, OS and software frameworks. You as a developer just need to provide your code or some logic that the service will perform. What particularly makes PaaS services interesting is that as a low privilege user or a user who only has read permission, you have the ability to read the source code or the logic that is defined within them. And in some cases, you can even read some of the variables. So if proper secret management is not in place, it provides a good avenue to discover additional credentials. So the first one that we have here is Azure Function. So Azure Function is one of those services where we provide the source code, and when a specific event occurs, it will run that source code. Yeah, as previously mentioned, the source code that we see here will be able to be extracted by a user that has got read privileges in Azure environment. The next service is Azure Automation Runbooks, which are very similar to Azure Function. functions, but have a slightly different use case of when you will use them. So similarly, you provide code and it executes when a certain event occurs. There are variables that can be supplied to the runbook. These variables can be encrypted, but since that is optional, at times you will find that they're not encrypted, and if there are sensitive information there, it'll be useful to look for in that location to see if there are credentials you can use to escalate your privileges or perform some other malicious activity. Lastly, we've got Azure Logic Apps. Logic Apps just essentially provide a further abstraction to function apps where you don't provide source code, where you just provide your specific essentially logic or actions, they call it in Azure. So as you can see in this particular example, there's an email that is fired off after a certain period of time. This all under the hood is just a JSON object, and that JSON object can be pulled and we'll be able to get whatever information that this logic app workflow defines. So there are tools that that perform actions like hunting through your environment for credentials. One of them is Microburst, provided by NetSpy. It's got an Azure commandlet that does essentially this, going through different services, trying to pull credentials. We're only going to be focusing on ones that, sorry, last bullet point is cut there, but yeah, we're only going to be focusing on the ones pulling credentials from services where we can do from a low privilege user. So let's get into it. Right, so the first thing we're doing is we're going to authenticate to Azure using the service principal we previously discovered. Don't worry, all these credentials have been deleted, so they are not useful as of today. So we're going to then go ahead and list the privileges that are assigned to this service principal. So we're using Azure CLI to perform all these actions. So we'll just give that a second. What we can see here is that there's a AD Lab resource group where we've got reader role permissions. So using that, we are going to get a list of what logic apps exist in our Azure environment. So we put it together, that query, give us all workflows that, and get only their name attribute. So we can see there's only one here. So what we're going to do next is dump out the definition of that workflow into a JSON file. Okay, now that's all done. So let's open it up and see its contents. Right, so what we can see here is there's an action which is called HTTP, where there is authentication credentials that are there. So this action was probably attempting to authenticate to another system, and the way the developer went about it is just hard coding the credentials instead of securely storing them into Key Vault or a similar secure storage mechanism. So what we will do now is take the client ID and then also grab the secret. Okay, and then once this is all set up, we'll just authenticate again into Azure and then do the same thing as we did before. Let's try to see what permissions we've got. All right. Okay, so we're running the command now. And yep, we've got the output. So for the AD Lab resource group, we have contributor rights, and we altered this with our user who just had reader role permissions. Oh, sorry, the service principal that had reader role permissions. step into the next slide. So a challenge that you might face is that when you review the logs for all the actions that we perform here, you'll notice that none of it is actually visible in the main log source for this, which is activity logs. This is because Azure doesn't log any read operation. It only logs all write operations which are performed by put, post, or delete HTTP requests. So it does leave us with a bit of a blind spot. So what we'll need to do is look at the very first action we performed, which was logging into an environment to see if there's anything there that could indicate that it's a malicious user using this service principal. Yeah, so this information is available in Azure AD. So what we have here is a screenshot of a log event where the service principal we used was logged into Azure from a specific IP address. We can even get to the country information if that is useful. So in terms of detection, I think that might be useful exploiting is that service principals themselves are typically predictable. Since they're associated with an application, they're likely to be running on a specific server or a resource that's in the cloud. So their location is fixed and the set of actions that they'll be performing is likely to be predictable. So using a combination of these two attributes, it is likely that you might get high fidelity detection use cases that you can put up together. Right, so we're moving closer to achieving our objective. To be able to do that, we'll explore moving laterally onto a resource that has the specific information that we want to get. But more broadly, let's just look at some of the objectives a malicious user might have. So a malicious user might want to steal personal identifiable information, steal financial data, or intellectual property that the company might hold. So for this current lab, we have set up a VM that has sensitive information stored in it. So we will look to getting access to that information. So if we just look at some of the ways we can move laterally onto a VM, one way would be to deploy an SSH key. And then with us having hold of the SSH key, we can SSH into the box. Another method that's available to us is using invoke run command, which is part of the Azure CLI tool, which allows us to specify a script or a specific PowerShell or bash command that will run on our VM. Thirdly, we've got another approach which is similar to the invoke run command, but how this one works is it deploys an extension, and the responsibility of the extension is to run a script. So we can specify details about that script, and then we would achieve code execution on that server. So one thing to note is that each of these three techniques that we discuss involves us running some code on the VM. And since organizations are likely to have traditional monitoring under control, it's monitoring in Azure VM lends itself well to this fact. So let's see if there's other ways that we can get access to information stored on the VM without actually executing any commands on the VM. So let's talk a little bit about how a VM, or what makes up a VM. So a VM is made up of these 4 resources. So you get the VM object itself, which has all the metadata information about the VM. Then we've got a network interface, which provides us information, which can have a private IP address associated with it. and a public IP address. And then we've got a managed disk, which is where our OS sits. So the fact that a VM is made up of this in this modular fashion, we can use this fact to copy aspects of it that we are interested in. So what we will do in the next lab is make a copy of the VM disk so that we can mount it in our own VM and explore the contents of that disk. So yeah, just reiterating what I just said. So what we'll do is we'll make a snapshot of the VM. And then once we've got a snapshot of a VM, we will take that snapshot, create a new managed disk, and then either deploy or find another VM that's in our environment but is not monitored. And then using that managed disk and mounting it as a data disk in our VM that is under our control. Right, so let's jump into it. So what we're doing here is we are getting information about our target VM. What you'll see here is a long string which represents the ID of the disk. So we'll just get that disk ID and store it in an environment variable. So we've got it now in environment variable. Next thing that we'll do is create a snapshot of the disk. Right. So now with the snapshot, what we will do is create a managed disk. So this is a brand new managed disk. The reason we're doing this is that you can't directly mount a managed disk that is connected to a VM. So we're just creating a fresh new one. So we get the ID of the freshly created managed disk. Next thing what we'll do then is attach it as a data disk to our VM that we have under our control. Okay, so this does take a bit of time, so I'm just going to try jump ahead. Okay, this should be fine. Right. So the disk is attached to our VM. Next thing we'll do is SSH into the VM. Once we SSH into the VM, we will list all block devices that are available to us. The last one we have an interest is the SDC one, so we will create a new folder where we will mount a partition from that drive to our local file system. So let's now change into the drive folder, go into the user's home directory, and then see what contents we have available. There's our target file we're looking for, and we can cat the contents and retrieve that information. Okay, so we're going to directly jump into monitoring and see what events we can get based off the actions that we just performed. So back here, we are at a log analytics workspace. Let me just start the video. Yep, so we're at our log analytics workspace. I've put together a query where we will search all actions performed by the object ID of our service principal. So I'm just ordering the events. So you'll see here there are a group of 3 events: creating a snapshot, updating disk, and then updating a virtual machine, which are the 3 actions we performed. You'll see that it's repeated 3 times for each. That's not to say that the event occurred 3 times. It's just the specific operation goes through a certain life cycle, starting with Azure acknowledging that they received it to eventually acknowledging that the command succeeded. So if we look at one of these ones a little bit more, we can see we can get useful information such as the IP address, which will be useful when we start thinking about things such as detection. Right. Okay, run through it again. So the first thing we did is we created a snapshot, and then we created a managed disk, which is represented as the create or update disk operation. Lastly, we attached the disk to the VM that we controlled. So yeah, that brings us to the end of our workshop. Let's just take a broad look of what we covered and what we have learned in these 3 labs. So yeah, first thing is that attack simulation is useful to perform. It provides a lot of useful information about the log events that occur when attacker is performing a certain action, and this is the fundamental information you need if you're going to be thinking about detection. Secondly, cloud detection can be tricky. So you'll notice in all the log sources, there was no clear sign of the tool that we used. It was all just legitimate operations that we're performing. So individually, it might be quite difficult, if not impossible in most cases, to spot malicious activity from one event. So you likely need to group multiple events together to get some context of what the actor was doing. Thirdly, yeah, keep track of your service principals. Service principals can have high permissions associated with them. They don't have, you can't enforce multi-factor authentication. And as you can see, they can be in your source code or in places where they are stored in unencrypted fashion. So knowing where they are is useful when you want to track if they are being used maliciously or not. Lastly, yeah, it's good to understand what normal looks like in your environment. Highlighting normal in your environment, since each environment will be performing different things, and using this sort of template of what normal looks like in your environment, you can use this deviations in how the service principal is being used or any other aspect to sort of try see if what's happening is malicious or not. Yeah, thank you all for taking time out of your day to listen. Yeah.
Awesome. Awesome. Thank you
from my side.
Awesome, man. Thank you for very much, and thanks to everyone for joining. I guess just to reiterate something we were saying at the top there, the lab guides are available now. You'll see that Becky's put them in the Q&A right now, so you can go and look at them now. A link to the Terraform to spin up the lab environment is also available through those lab guides. And the slides and a recording of this session will be available most likely tomorrow morning as well. So you can watch that back at your leisure and go through them kind of as you want to. But otherwise, it just remains for me to say thank you for joining us again for the series this year. Hope you enjoyed it. Feel free to reach out to us on Twitter or via email. And we look forward to hearing from you if you've got any other questions. So thanks, guys, and hopefully see you next year.